This is Mark Anderson for Kellogg Community College, and we're going to be looking today at the circle and some of the properties that it has. But first, before I introduce you to the circle, I want to kind of take you back a little bit to maybe your geometry class, where you learned that right triangles have some properties relating their legs, which we will mark as A and B, to its hypotenuse C. Now, the legs are the straight sides of a right triangle, and if we measure the distance of one of the legs as A and the other leg as B, we can come up with a distance formula for C with the relationship A squared plus B squared equals C squared, and we call that the Pythagorean theorem. But what instead of having distances for A and B, we have coordinates for the points at the end of A and B, stemming from the right angle. So let's say that we have a point marked as -10, 6. So this would be west of the origin and north of the origin in the second quadrant. And then we have another point in the second quadrant as -7, 2. We can use these points to determine our length of this distance d, or the hypotenuse of this right triangle here. And to do so, what we would do is slightly modify A and B. In fact, the distance of A, which would be along this x distance from here to here, can be represented by x sub 2 minus x sub 1. That would be the distance between the two x coordinates of that point. Squared would give me the same distance as A squared. Then we add, just like we do over here with the Pythagorean theorem, our y sub 2 minus y sub 1, which is the distance of our y's along this dimension, which would give us our distance b. So a squared plus b squared is equal to c squared. Now in this case, we're not going to use the letter c, we're going to use the letter d, and to actually find the distance of d, we would take the square root of both sides to get my d all by itself. So this is my x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. So if I was to find this distance, I would plug in my x values, subtracting the x. Now, the subscripts sometimes are taken very literally as the second point minus the first point, but since we're actually squaring the differences here, as long as you take the points in the same order, either from left to right or right to left, you will get the same answer. So let's take the points from left to right, so -10 minus -7, so this is -10 minus -7, quantity squared, plus 6 minus 2, quantity squared, equals distance. So if we do some simplification here, -10 plus 7 is going to be -3. And that quantity squared is underneath the square root still, plus 6 minus 2, which is 4, quantity squared, and that is going to make 9 plus 16 under the square root, which is the square root of 25 under the square root, which is 5. So our distance in this problem happens to be 5. Because if you'd actually now, if we had this actually on graph paper, you would count that there is a distance of 3 between our x here, from here to here, and there's a distance of 4 between our y from here to here. And in many of my early geometry classes at the middle school or high school, we would actually count squares rather than use this distance formula in the first step. We would actually count squares to go, okay, here's our a squared plus b squared equals c squared. And that relationship then gives us our distance of 5. Now, what you have to imagine, though, is imagine that this point, -7, 2. Imagine if we took a nail and we hammered a nail into that spot, and this distance d was fixed, but allowed to spin around that center dot. You will note that if we spun that distance d around that center spot, we would create a circle. So this distance is no longer the letter d, it would be the letter r for radius. So we are now going to imagine a circle with radius 5, and we are going to basically use this equation here to kind of derive it. So instead of having x sub 2 minus x sub 1, we're going to have that x value that can spin around the circle will be subtracting our h value, which is going to be the center's x value. So our center dot is going to have our h right here, and then our k, which is going to be the y coordinate of our center, will be after this one. So for a general circle, we will have a center h comma k, and the x and y created by spinning that fixed radius around in a circle, that will give us our r at the end. So let's just now take a step back and look at how we got here. We started off with the Pythagorean theorem, and then we expanded that out to the distance formula. But knowing that if we have a circle, the fixed distance of that circle is created from a center. And that center, what we just did is created our x sub 1 to be our h comma k. So our circle formula in standard form is going to have a center with the parenthesis of h comma k. But you'll note that they are being subtracted. And to get us to the actual general form of the circle formula, we will square both sides. So this is what you would normally see: x minus h quantity squared plus y minus k quantity squared is equal to r squared. This is the general form for a circle. So if we were actually looking at a circle with the center at 2 comma negative 4, this would be x minus 2 squared plus y plus 4 squared equals, now here we have a radius of 5. We're assuming the radius is 5 from the previous example. This would then be 25. So if I gave you this formula, I could then reverse it to say that the x coordinate would be 2, the y coordinate would be negative 4, opposite of what you see, and then this would have a radius of 5. Most of the time, these numbers here will be easily square rootable, but in the case you don't have an easily square rootable number, type it into your technology and approximate with a decimal. So let's actually expand this idea using the standard form to sketching some circles of graphs. Now what I will do is rewrite the general form one more time. The general formula for a circle is going to be x minus h quantity squared plus y minus k quantity squared is equal to r squared. So my center is going to be at the point 1 comma negative 1. Let's explain that a little bit. This is my h and this is my k. This is my h here and this is my letter k here. You'll notice that these are opposites of what they are here because according to the general formula, you're subtracting h, and that h value is the number that's being subtracted. Here, the y value for our center, or letter k, is going to be this negative 1, because what we see is a positive 1. And so how we get a negative 1 is we look at subtracting a negative. So our radius is going to be the square root of this, because according to the general formula, this number here is the radius squared. So if I'm given the radius squared, to find the radius, we would take the square root, and that would be 2. To plot this circle, you would need to do, for at least my class, at minimum 5 points. So you would first of all start off with the center, which is 1 comma negative 1, or here, 1 on the x, negative 1 on the y. Now the radius is 2, so I would require in my class 2 points in either direction, and then create the circle around it. And that is my circle. A circle with center at 1 comma negative 1 and a radius of 2. I choose the north, south, east, west points to plot because they are easier to plot than the diagonals of this circle. So I find this is the easiest way to go. For my next example, I'm going to use the circle formula again, noticing that my h and k, which is going to be my x and y coordinate of the circle, we can now look at the center as negative 2 and positive 3, or opposite of what you see. So we're going to go with negative 2 and positive 3 and put a dot there for the center of the next circle. Now my radius is going to be, well, first of all, my radius is represented because in this equation this is r squared, So my radius is 3. We would have to take the square root of this to find my radius. So 1, 2, 3 in either direction. 1, 2, 3, 1, 2, 3, 1, 2, 3. In either direction, we make a beautiful circle here. There it is. There is my circle. All right, let's do 2 more before the end of this video here. This is an example of finding and actually the what's given in this problem is practically everything we need to sketch. They give us the center at 2, -3, and now we have to find, using a radius of 3, we're going to make a sketch of this. So 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Here we have a beautiful circle. But the question is, it says write an equation about this. Well, the equation is going to be, again, x minus h quantity squared plus y minus k quantity squared equals the radius squared. So we will plug into this equation x minus h, which is going to be x minus 2. And here we've got y minus k, and it's already a -3, so that means we'd have to have y plus 3, or y minus 3, or minus -3, which gives us the positive 3. Now the radius is r squared, so if our radius is 3, then our general equation would have to have an answer of 9. So that is the equation, and I wrote it below this line. It would really go up here in this line right there, but this gives me just a little bit more room to write it. So for our final problem today, we're given a little less information, but enough information to solve this. It says, find the equation of the circle that passes through the point -1, 2. All right, so that's right here, and whose center is 3, -1. So what we have here is we have a center, so here's my h and k, and my equation is going to be now x minus 3 quantity squared plus, over here, y plus 1 quantity squared. But what I don't know is I don't know my radius. I do know that this is a distance from that point to that point, but I need to find my distance as a of this radius right here. Now, if these dots were right above each other, below each other, or side to side, this would be really easy to measure. But since this is a hypotenuse or a diagonal, what I'm going to use is the distance formula. Now, you can kind of argue with me a little bit about, using the distance formula, because you can just say, well, I could just use the equation of the circle formula because I know my x minus h, right? And I know my y minus k. I actually know all these. I know a point on the circle, and I know the center on this circle. So therefore, if I do this computation, I can find my distance d. So let's just do that. And if you wanted to use a straight up distance formula, you would just go x2 minus x1, y2 minus y1, and use these points. So let's actually still use this equation here. So I'm going to pick my x as -1, my center. Oh, I just wrote a comma there. I didn't mean to do that. -1 minus 3 quantity squared. And then I'm going to have a 2 minus 1 quantity squared. So my distance is going to be the square root of -4 quantity squared plus 3 quantity squared. And this should look a little familiar. If we wanted to go back to the original equation, I think you can see what I'm talking about. This is the square root of 16 plus 9, or the square root of 25, or the distance is 5. Now the distance also happens, this distance d also happens to be the radius. So that radius is 5, so this would be represented as 25 in our general formula. So from this dot, we will go up 5, 1, 2, 3, 4, 5. We'll go over 5, 1, 2, 3, 4, 5. We'll go left 5, 1, 2, 3, 4, 5, and down 5, 1, 2, 3, 4, 5. Just making sure I didn't skip anything. 1, 2, 3, 4, 5. Okay, so as I finish my circle, let's see, 1, 2, 3, 4, 5. Okay. As I finish my circle and try to do the best freehand circle I can draw, you can see as I come around this arc, I do end up going through that point to some degree. And there's my sketch of this radius with 5 centered circle at the point 3, -1. All right, well, thank you for watching my video on circles. I hope this has helped explain some things. And as always, thanks for watching.